Hello, and welcome to Backer Breaks It Down. In this episode, we are going to find tangent, sine, and cosine ratios, and we're going to use them to solve for unknown side lengths in right triangles. So previously, we've done this, okay? So tangent. Tangent is the ratio of the leg opposite a given angle over the leg adjacent to a given angle. Okay, so like here in this diagram for triangle ABC, A is that given angle, and directly opposite angle A is that opposite leg. Okay, the leg adjacent to angle A is obviously the adjacent leg, and then the hypotenuse is always going to be opposite the right angle. That never changes. So we did problems 1 and 2 here. Okay, we found, when it was angle D, that was our reference angle. The side opposite angle D was the 36 unit long side, and 27 was the adjacent. When we went and found tangent of angle E, those were reversed, okay? Because the reference angle dictates opposite and adjacent sides. We've also have found sine and cosine ratios. Sine is the ratio of the leg opposite over the hypotenuse, and cosine is the ratio of the leg adjacent over the hypotenuse. So once again, pay attention to what's your reference angle, because that reference angle determines opposite and adjacent sides. Okay, so how can we use these to find missing sides in a right triangle? Okay, so basically you should definitely look at the diagram, look for the reference angle, and then ask yourself, what do I know? So do I know the opposite? Do I know the adjacent? Do I know the hypotenuse? And what am I trying to find? Okay, and then determine which of our 3 trig functions fits. Okay, because I can use sine if I'm working with the opposite and the hypotenuse. I can work with cosine if I'm working with the adjacent and the hypotenuse. And I can use tangent if I'm working with the opposite and the adjacent. So what do I know? What do I need to know? How can I find it? That's how we want to approach these problems. Okay, and then one other thing to know before you go doing any calculations is check your mode. So there's a button on your calculator. It says mode. Make sure degree is highlighted, okay, because that's how we measure angles at this level. It's in degrees, okay? So let's do this, okay? Write a trig equation using tangent to find the indicated side length x, okay? I'm not always going to tell you which trig function to use. You need to figure that out, okay? But 61 degrees, it's like, well, what do I know, right? Well, I know the side opposite that angle. What do I want to know? I want to know the side adjacent to that angle. So it makes perfect sense to use tangent, okay? So I can write an equation that looks like this. Tangent of the angle, so tangent of 61 degrees equals opposite, which is 22 over x, okay? So that's my trig equation. So how would I go about getting x all by itself? Yeah, I'd first need to get rid of the x in the denominator by multiplying both sides by x. So now I have x times tangent of 61 degrees, and this equals 22. So now, how would I get x all by itself? Exactly. I would divide both sides by tangent of 61 degrees. And so, in my calculator, that's what I want to do, because x is equal to 22 divided by tangent of 61. Okay, now in trig, we generally round side lengths to 2 decimal places. So we can say in this problem that x is approximately 12.19. Okay, so let's take a look at another one. So number 4, I'm already telling you to use tangent, okay, but do you see why? So the angle we're working with is 56 degrees. What do I know? I know the side adjacent to that angle. What do I want to know? I want to know the side opposite that angle. So of course, I'm using tangent. So I'm going to write my tangent equation. I'm going to be like tangent of 56 degrees is equal to the opposite over the adjacent. Now notice this time x is in a different place altogether. It's in the numerator. So how do I go about getting it by itself? Yeah, I simply multiply both sides by 13. And now x is all by itself. It's even easier, right? And so x is equal to 13 times tangent of 56 degrees. And this is what I'm going to calculate. And so we can say that x is approximately 19.27. Okay. So I'm going to skip to some sine cosine problems. Okay. And in problem number 5, I want to find df. That's what they're telling me to find. So I'm just going to call df by the variable x. And so just like before, I want you to ask yourself, what do I know? What do I need to know? And how can I find it? Right? So I know that angle D is 51 degrees. And I also know the side opposite that angle. What do I want to know? I want to know the hypotenuse. How can I find it? Well, sine uses the opposite and the hypotenuse. So clearly, I want to write a sine equation here. So I'm going to say that sine of my angle is equal to the opposite over the hypotenuse. And then it's a matter of doing algebra to get x by itself. So we can multiply both sides by x, divide both sides by sine of 51. Ultimately, we are going to get x is equal to 17 divided by sine of 51. And that's what we're going to calculate, rounding our answer to 2 decimal places. And of course, I've already got that ready to go. And we get 21.87. Okay. So in problem number 6, we want to find ST. So I'm going to mark that with an X to make it easy for us. And so then what do we know? What do we need to know? How can we find it? Well, we know that angle T is 42 degrees. And we know the hypotenuse is 9.5. What do we want to know? We want to know the side adjacent to the 42 degree angle. How can we find it? Well, the problem involves adjacent and hypotenuse, and that is cosine. So I'm going to write a cosine equation. Okay, so I'm going to have cosine of the angle, so of 42 degrees, is equal to the adjacent over the hypotenuse, so x over 9.5. And then to get x all by itself, I'm simply going to multiply both sides by 9.5. So I'm getting 9.5 times cosine of 42 degrees is equal to x. And that's what I'm going to calculate. And I've already done that. And I got that x is approximately 7.06. And so that's how we can use these trig functions to find missing sides in right triangles. Simply ask yourself, what do I know? What do I need to know? Can I find it? Okay. So by asking yourself, what do I know? What do I need to know? You will be like realizing, oh, I'm either working with the opposite and the hypotenuse. So I'm going to write a sine equation. Or I'm working with the adjacent and the hypotenuse and thus cosine. Or I'm working with the opposite and the adjacent, therefore tangent. And that's how Backer breaks it down.